Hello friends, welcome back to our channel. So today we'll see one more concept in computer organization, that is addressing modes. So in our previous session we have discussed about the instruction format, and also we have seen the design of the control unit, that microprogrammed control unit. So coming to the design of instruction, so the instruction format will be having the three fields. So the first one will be the mode, either it is a direct or indirect. The next one will be the opcode, so which will give you the operation, what kind of operation need to be performed, and the next one is the address. So here, how to identify this address? So that is nothing but our addressing modes. So how many ways we can give the address or we can represent the address? So in some cases, in this place of address, we will give a operand. So which is nothing but some memory location, right? Some memory. So in that memory, the actual data will be available. So instead of address, we can give the operand or a register. So even instead of passing the operand, we can also pass the register, so that the address will be available in the register. Or sometimes we pass a constant. So instead of memory location, we can also pass the constant. So that can be applied to the accumulator. So here, how to get the effective address to perform some operation is known as the addressing mode, right? So this addressing mode specifies the effective address in order to perform specific operation. So how we have to perform the operation, on which data we have to perform the operation. So that is called as an addressing modes. So there are a lot of addressing modes. Now I'll list out all these things and then we'll see one by one how we can represent the instruction format in each and every addressing mode, right? Now I'll write the complete addressing modes here. So the first one, implied or implicit. I'll erase all this one also. Implicit addressing mode. So in this implied or implicit addressing mode, there is no need of giving the operand. So here, no need of specifying operand or memory address. So here the data will be included in instruction itself. That means here we need not specify any operand or memory address or any data, right? So for example, I'll tell you the example so that you can easily identify or understood this one, right? So let it be CLA. So CLA is a command or an instruction which will perform the clearing of accumulator. So here we are not specifying any kind of address or any kind of operands or registers, right? So this is a single instruction which will clear the accumulator. So we have seen the design of accumulator also. Accumulator is a processor register, right? So which is used to store some intermediate results of arithmetic operations, right? So CLA or RAL, which means rotate. The content of accumulator will be rotated to left with some cap. carry, right? So these kind of instructions doesn't require any address or doesn't require any operand. So the instruction itself will be having the data or some operation, right? So we can also call it as an operation which we need to perform, that should be included in the instruction itself. Simply by using CAA, it will clear the accumulator. Simply by using the RAL, it will rotate the content of accumulator to left with along with the carry, right? So that we call it as a implied addressing mode or implicit addressing mode. The next, second one, stack addressing mode. Stack addressing mode. So what is this stack addressing mode? So here the stack itself indicates, so we will be storing the data in last in first out. Okay, so last in first out format. So whatever the data we are inserting last, that should be taken first. So in the same way here, always the control points to top of stack. So the operations will be performed on the data which is at the top of the stack. Will be performed on data which is at top of stack. For example, the instruction add. So the instruction add means it should add some it should have the two operands, right? So initially if you use this add, this performs addition on two operands at top of the stack. And again the result will be again stored in the top of the stack. Okay, so here also we are not specifying any particular operand, but the operation will be performed based upon the stack operations. That means whatever the data available at the top of the stack, that will be retrieved from the stack, that means popped from the stack, and then the operation will be done, and again the result will be stored back to the top of the stack itself, right? So that is a stack addressing mode, and this is an implied or implicit addressing mode. And the next one, is immediate addressing mode. So what is this immediate addressing mode? So in here the operand is a constant which is prefixed with hash symbol. So whatever the constant, that will be directly initialized to some register. So that is called an immediate addressing mode. So there will be no there will be no memory. So directly the constant will be assigned. For example, you can see add R1 hash 10H. So immediate means without any memory address, we are directly representing the constant. Otherwise you can also go with LDA 10H. So this instruction will directly store this particular value. So if the value is prefixed with hash symbol, that implies that is a constant, that is a value, that's not a memory address. So that will be directly loaded into the accumulator, that is directly initialized to the accumulator. Here also we are initializing some sort of constant to the register R1. So this we call it as a immediate addressing mode. So immediately we are giving some sort of constants, okay, in order to execute the operation. And the next one, direct addressing mode. So almost you are familiar with this one, because already we have studied this direct addressing mode and indirect addressing mode in the instruction cycle, right? So once again we'll see direct addressing. That means the address will be directly having some operand. So here address will directly refers the effective address of operand. Right? For example, see, first I'll write down the diagram. So let us consider the two fields. One is opcode. Okay. So forget about the last one, that means a mode. Okay. So we can include the first and second columns with the opcode, right? So opcode, and the next one is the address. And whatever the address we are having, that will be directly pointing towards the memory. So this is a memory. So in this memory, we'll having the direct operand. So this operand can be a constant or any register, no problem. But it is not a address. So directly this address refers the effective address of the operand. So this is an address, effective address. So this is the effective address of the operand. So whatever the address we are giving here, that is directly reference to the operand itself. Okay. So simply you can say, so for example, so add, let it be R. So this is nothing but accumulator which is added with the value at this particular address. For example, suppose, just imagine if you are using some square braces, that implies that is the memory. Okay, here R is a memory, and if I am including, representing that R in between the square braces, that means the address, the data which is available at that particular memory. That means whatever the value here. So for example, let it be some 10. So accumulator plus 10. Okay, so this is called the direct addressing mode. So directly the address in the instruction format will refer to the effective address of the operand. So that we are calling it as a direct addressing mode. Coming to the indirect addressing mode. So indirect addressing mode, here the quite opposite with this one. So here the address will refer to address of operand. So that means that two memory references will be there. So here we are having only one memory reference. Okay. So here we are having only one memory reference in order to fetch the instruction, memory reference. But here address of instruction format will refer to the address of the operand. Okay. For example, I'll show you. So this is the instruction. So this one is the opcode and this one is the address, for example. And this points towards the memory. Okay, what we have discussed just now. So this is a memory. So this address will represent, so let it be the operand is here. Okay, the operand is here. So let it be the address is some 1000. So this 1000 will be representing here. So there will be a connection. I write here. So there will be a reference towards this particular operand. Okay. So address refers to address of the operand. So here address refers to 1000, which is the address of the operand. Okay. So here we require two memory references. Two memory references in order to fetch the instruction. Two memory references. That we call it as an indirect addressing mode. Indirect addressing mode. Okay. Next. Register direct. Excuse me. Sorry. The next one is a register direct addressing mode, which is sorry. So the next one is a register direct addressing mode. So here this is also similar to direct addressing. But what's the difference means, here the address will be stored in the register. So here instead of address we will call it as a register. Okay. So here for this one the example will be some add R1. So which can be treated as accumulator plus two boxes with R1. So that means address inside the address. And here see, coming to the register direct addressing modes, address will be available in the register, which refers to the effective address of the operand. So instead of directly giving the address will be stored in the register itself. Okay, that's the only difference. So here we will give some register value. So the same thing. Here there will be no memory reference. So directly it will reference to the operand. Okay, directly it will reference to the operand. And the same thing, the next one is a register indirect. Register indirect. So in this register indirect, so here also instead of address we will be having some register. So the register will be pointing towards the effective address of the operand. So here we will be having the address and that will be copied. So only one difference between direct addressing mode and the register direct addressing mode. So in the direct addressing mode, we'll give the address directly, but coming to the register direct addressing mode, the address will be stored into the register itself. Similarly, register indirect addressing mode, right? So the rest of the execution is common. And the next one, relative addressing mode. See, these many ways we can refer the effective address. That means I calculate the effective address in order to perform the operation, right? So the next one, relative addressing mode. What is this relative addressing mode? So in order to get the effective address, see, I'll write the formula here. Effective address. How we can get the effective address? So that is the content of program counter. Content of, I'll write it as a PC, program counter will be added with the address in instruction format. Address in instruction format. For example, if the content is like this, see, this is the opcode and this is the address, and this will be added with the content of program counter, which will give the effective address in the memory. So this is the memory. Okay, this is the memory, and this is the operand. Right, this is the operand. So adding the address of the instruction with the content of program counter will give the effective address of the operand to perform the operation. So this is called as a relative addressing mode. So this is very important. Effective address will be the addition of content of a program counter. So we know that a program counter will be having the address of the next instruction going to be executed. So that will be added with the address to get the effective address of the operand. And the next one, indexed addressing mode. So here in this indexed addressing mode, effective address will be content of index register, content of index register plus address. See, we'll be having the opcode, and then we'll be having some index register here. IR, I am writing the shortcuts. IR means index register, and this is the address. So here we'll be having some register set. So the complete content of registers will be here. So register set, and for example, this is a pointer. So this will be added with the address, and finally we'll get the operand, that means effective address. So this is the register set. From here, that will be added to the address of the instruction, and that refers to the operand of memory. So this is called the indexed addressing mode. Okay, so the next one is base register addressing mode. Base register addressing mode. So this is also simple. Instead of IR, we will be having the BR, base register. So here also we will be having the base register. So the content of base register will be added with the address of instruction, which gives the effective address of the operand. So that is called as a base register addressing mode. Okay, and the next one, auto increment addressing register, right? So here, instead of getting the address, see, I'll write here auto increment addressing mode. Auto increment addressing mode. So here what happens means there will be a register. So this is an opcode, and this is a register. Okay, and this register will be pointing in the register set. Right? So this is a register set which will be having a lot of registers. Register set. Okay, and this register will be pointing towards the memory. For example, so here now the register is here, and that is pointing towards the memory. For example, let us take the same thing. So this is a 1000 memory address. Okay, 1001, 1002, 1003, 1004. Right? So for example, here it is an operand. Now, immediately we know that already the address of the next instruction will be stored in the program counter. So once it was fetched from the program counter, immediately the program counter will be incremented. So similarly here the register will be incremented towards here. So I represent it as Ri. Ri means after increment. So obviously this will be pointing towards somewhere else. So this is a Ri and this is R. So that means automatically it will be incremented towards the operand. So the same way the next one is auto decrement. Auto decrement addressing mode. So in this auto decrement, let it be the operand is here. Let it be the operand points here. Let it be here R and it is pointing towards here. Next immediately it will be decremented and now Ri will be here and it will be pointing here. So this is a Ri and R. Ri or Rd. We can represent it as a D. Rd means decrementing the register. So this is also automatically done, right? So register will be automatically decremented and it will be pointing towards the operand of memory. So this is a memory. As usual, it's a memory, right? So these are the different ways to calculate the effective address in order to perform the operations. So what we have seen, implicit or implied addressing mode, and then stack addressing mode, and then immediate addressing mode, and then direct addressing mode, indirect addressing mode, register direct addressing mode, register indirect addressing mode, relative addressing mode, and then again index based addressing mode, base register addressing mode, and auto increment addressing mode and auto decrement addressing mode. So these are different addressing modes to calculate the effective address, right? So let's stop here. And if you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.